Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 2 video on the chapter of cubes and cube roots where I will solve more problems from the exercise 4A and 4B. In the previous part 1, I discussed about the cubes of a number, perfect cubes, prime factorization method to check whether a given number is a perfect cube or not, and discussed about two very standard typical problems based on cubes of a number. So I could not solve uh, quite a few, I could not solve enough problems from the exercise 4A and 4B because my machine was running very slow. So I had to stop. The video. So in this video, I will try to solve more problems from exercise 4A and 4B, which is based on cubes of a number. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly, and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have the problems from exercise 4A and 4B on the left hand side, and on the right hand side I will do the solving and discussion of concepts applied to solve a problem. Okay, so let's start solving the problem. This is exercise 4A. Perhaps I will not solve all the problems, but majority of the problems, so that you get an idea of how to apply the concepts to solve the given problems. Okay, the first one is evaluate. Okay, the evaluate, you have to find the cubes of some given numbers. Now, if it is a two-digit number, you can apply the column method to solve to find the cubes. Otherwise, you can also do it orally if you find the column method to be time consuming. Now, the first one is very trivial, 8 cube. You can also solve it like this. This 8 cube is 8 multiplied by 8 square. This is equal to 8. 8 square we know is 64, and then you find it 512. Okay. Part 2 is 15 cube. 15 cube is equal to 15 multiplied by 15 square. This is 15 multiplied by 15 square is 225. And now you can do this by the normal multiplication method. You can do this by normal multiplication method like this. But for two-digit number, if it is a little for two-digit number, you can also do it use the column method. That might save a little bit of time. Now this multiplication method we all know, so there is nothing to do new in it. Let's try to do it this 15 cube using the column method. So quickly, I know in the form as per the notes. If you have not watched the part 1 video, I strongly suggest that you watch that video to get an understanding of the cubes of a number, prime factorization method to check whether a given number is a perfect cube or not, and how there are some properties of cubes. Okay, so 15 cube, we know the x, the digit in the tens place is 1, and y, the digit at the units place is 5. So what do? We create a table. With 4 columns. And with headings x cube and 3x square y, 3xy square, and y cube. Now we have to write the values of x cube, 3x square y, and 3xy square and y cube below the headings. So x cube, x is 1, 1 cube is 1. 3x square y, 3 into x square is 1 and y is 5. So this is 15. 3xy square, 3 into 1 y squared is 25. So this is 75, and y cube is 5 cube, that is 125. Now we start from the rightmost column, that is y cube. You mark the units digit, that is 5, and you see that there are more digits, that is, and those digits, the extra digits apart from the units digit is 1, 2, that makes the number 12. We have to add this 12 with the value of the previous column, that is 75. So we add 12 with 75 and we get 87. Now in this the final value of the third column, you mark the digit at the units place, and you see there are more digits. So the number forming the more digits apart from the units digit 8, you have to add with the value of the previous column. So we will add 8 to 15 and we get 23. Now 23, the digit, mark the digit at the units place 3, and you see there are more digits 2. These two similarly you have to add with the previous you have to add 2 with the value of the previous column, that is x cube. So we add 2 with 1 and we get 3. Now what will be, now we have to form the value of the 15 cube. So 15 cube will be the value of the first column, that is x cube, the final value of the first column, which is 3, and then you append the units digit of the second column, that is 3. Then you append the units digit at the, from the third column, that is 7, and finally you append the units digit from the last column, that is 5. So 3375 is the cube of 15. I will check it quickly. Yes, 3375 is the cube of, okay. Now I hope I need not do the 60 cube, you can do it yourself. Okay, now let's do the problem 2. This is also to evaluate, find the values of some cube, but it has some decimal numbers. So part 1 is 1.2 cube. Now when you have to find the cube of a decimal number, always convert the decimal number in the fraction form. So 1.2 is 12 by 10. We have 12 by 10 cube. Now we know that 12 by 10 is a rational number. We know that the cube of a rational number, if rational number x by y is the rational number, its cube will be, as per the laws of exponents, cube of the numerator divided by cube of the denominator, x cube by y cube. So we will have 12 by 10 cube, it will be 12 cube divided by 10 cube. Now what is 12 cube? Now 12 cube, this will be 144. 12 square is 144 and multiplied by 12, and 10 cube is 1000. Now you have to quickly find what is 144 multiplied by 12. 88214. So we have 8, 12, 7, 1728. So this is equal to 1728 divided by 1000, which is equal to, in decimal form, 1.728. 1.728. Okay, let's do part 2. 3.5 whole cube. The concept is same, the logic is, the steps are same. Convert the decimal number 3.5 in the fraction form, it will be 35 by 10, and you have cube of 35 by 10. This is equal to 35 cube and by 10 cube. Now you have to find 35 cube. Now 35 cube. Now okay, so how do you find 35 cube? Now, if you try to find it by the normal multiplication, it will take a bit of time. So it's better if you can quickly, without you just quickly form the table using the column method. You have to very quickly find the values of 35 cube. So you need not write the name of the headings. You have to remember that mentally. So I know that over here it will be 125 5 cube 35. The digit at the units place is 5. So this will be 125. This will be 3xy square. Now you can write so that you can name this thing. You have to be very quick, and so that you should not be wasting a lot of time in finding the cube of a number using the column method. So 125 and 3xy square will be 9 25 25 into 9 25 into 9, which is 45 22 2 2 5. Okay, and 3x square y will be 3x square y 9. Okay, 9 27 into 5. 27 into 5 is 35 135 135, and x cube is 27. Now 5, and then this get added, plus 12. We have 2 3 7. This get added, 23 8 5 1, and this get added, 15 12 4. So 35 cube should be 4 2 8 7 5. So this is equal to 4 2 8 7 5 divided by 1000. This is equal to 442.875. Let me quickly check if I did it correctly or not. That is 35 cube is 42875. Okay, so now let me do what else can I do? I hope you got the idea, and you can do find the cube of any decimal. So let's see what is 0.8 whole cube. 0.8 in the fraction form is 8 by 10 cube, and this is equal to 8 cube by 10 cube. Now what is 8 cube? 8 square is 64. 8 cube is 512. Now the single digit cubes of all the digits you have to know, you have to remember, and also perhaps some very standard numbers, 2-digit numbers. You should also, if possible, remember the values of the cubes and as well as squares. So I have 512 by 1000. This is equal to 0.512. Okay. The part 4, 0.05 cube. So 0.05 is 5 by 100. We have cube. This is equal to 5 cube divided by, now 100 is 100 square, 10 square, sorry, and power cube. This is equal to 125 and divided by 10 to the power 6. This is equal to 0.000125. Okay, let's do problem number 3. Now, while I am solving the problem, you should quickly pause the video and take screenshot of the solution if you think it will help you in as a future reference. Okay. Problem number 3. This is also evaluate the cubes of uh, fractions or mixed fractions. Now, okay, so these are pretty simple. I will let's do two of them. Now 4 by 7 cube is nothing but 4 cube divided by 7 cube. 4 cube is 64, and what is 7 cube? 49 multiplied by 7, 63, 28, 34, 343, 343, 64 by 343. Okay. Part 2, 10 by 11 whole cube. This is equal to 10 cube divided by 11 cube. Now 10 cube is 1000 divided by what is 11 cube. 11 cube is 1 square, 11 square is 121. So 121 multiplied by 11, that is 121 and 121. It is 1331. So 1331. Let's do 4. 1 and this is a mixed fraction. If you are given, you are asked to find the cube of a mixed fraction, you have to first convert the mixed fraction as an improper fraction. So 1 and 3 by 10 is 13 by 10, this whole cube. So this will be equal to 13 cube divided by 10 cube. Now what is 13 cube? 13 is 13 square is 146. So 146 multiplied by 13, 18, 4, then 6, 4, 1, 8, 9, 8, 1898. So 13 cube is 1898, and then we have divided by 1000. This is equal to 1.898. Okay, let's do these are question. Okay, let's do problem number 4. Which of the following numbers are perfect cubes? In case of perfect cube, find the number whose cube is the given number. Now 125 is simple. I am not doing it. 5 cube is 125. Now 243 is also simple. Let me start with 243. We have to find whether these are perfect cubes or not using the prime factorization method. So we have to find the prime factors of 243. Now you can see it divides by 3. So 81, which is equal to 3 multiplied by 3 multiplied by 27. So this will be equal to 3 multiplied by 3, and we know 27 is 3 multiplied by 3 multiplied by 3. Now, so this is the prime factors. We have 5 3's. Now, if you have watched the part 1 video, over there I have explained how to use the prime factorization to check whether a given number is a perfect cube or not. So the first method was, anyway the prime factorization is the common part. You have to first find the prime factors. Then the first method was to find triplets, to form triplets of equal factors. So this is one triplet, that is a product of 3 equal factors. And so if you can form, if all the prime factors can be a part of any triplet, then the given number is a perfect cube. But we can see that 3 into 3, this is not a part of any triplet. So 243 is not a perfect cube. but okay, 9 square. Uh, so this is not a perfect cube since uh, uh, there are prime factors left behind which are not part of any triplet. Triplet means triplet means three numbers, that is product of three numbers, not part of any triplet of equal factors. In the triplet, all the factors must be equal. So in this example, only one triplet is formed, that is 3 into 3 into 3, and the remaining two, there are two threes, two factors of 3 are left behind, which is not part of any triplet. So this uh, is not a perfect cube, not a perfect cube. Uh, 3, it is 343. 343. This is, I guess, is a perfect cube, but I'm not sure. 749. No. 3. 343. 79. Yeah, I think it is 7 because 49 is 7 square. 49 multiplied by 7 is 63, and 28, 33, 4. So this is equal to 7 multiplied by 7 multiplied by 7, and we can clearly see that all the factors are part of one triplet. There is only one triplet. So uh, this is a perfect cube. This is a perfect cube, and from the prime factorization we can say that 7 into 7 from so what is, so if from the prime factorization, if we see that a number is a perfect cube, how do we find the number whose cube is that number? So we take one factor from each triplet. So the product of one factor from each triplet is the number whose cube is the given number. So we can see that so the triplet can be so we see that this is 7 cube. So the number whose cube is 343 is 7. 256. 256 is equal to 2. How many 2's will be there? 2 into 128. This is equal to 2 into 2 into 64. This is equal to 2 into 2 into 2 into 32. This is equal to 2 into 2 into 2 into 2 into 16 into 16. And so 16 can be written as, so we have 2 into 2 into 2 into 2, and 16 can be written as 4 square. So we will have 4 is 2 into 2 into 2 into 2. So how many? So let me. So we have to find whether we can. We have to form the triplets. So this is one triplet. This is another triplet, and we see that two triplets are formed. Triplets are formed, but two factors, that is two twos, are left behind, which is not part of any triplet. Not part of any triplet. So this implies that 256 is not a perfect cube. Okay. Let's see 3375, that is 7. Now 3, 3, 7, 5. The prime factorization is a very important step. You should be very strong at finding the prime factorization of any given number, which I am not good at all. I will divide by 5. So 6, 7, 5. I will again divide by 5. 1, 3, 5. Again divide by 5. 2, 7, and 27 we know. So this is 3375. His prime factorization will be 5 into 5 into 5, and definitely 27 is 3 into 3 into 3, and we can see we can form two triplets. One triplet is having equal factor of 5 and another triplet is having equal factor of 3. So this is a perfect square. This is a perfect cube. Since all the factors in the prime factorization is a part of a triplet. So what is the number whose cube is 3375? So from the first triplet can be expressed as 5 cube, and the second triplet can be expressed as 3 cube. So this is equal to 5 multiplied by 3 whole cube. This is equal to 15 cube. So the number 3375 is the cube of the number 15. Okay, what about now the 5 is pretty easy. 8000, we can consider it as 8 multiplied by 1000. This is equal to, we know 8 is 2 cube and 1000 is 10 cube. So definitely, as I said in the while discussing to test whether a given number is a perfect cube or not, anyway, if you have the given number in the form of powers of prime factors, then from the powers you can also tell whether the number is a perfect cube or not. So the number 8000, we can see it is 2 cube multiplied by 10 cube. Now of course 10 cube can be further. The 10 is not a prime number, is not a prime factor. You can write 10 as 2 into 5 and we have whole cube. So the actual factors of the prime with their powers will be, so this is 2 cube multiplied by 5 cube. Now if we add up the powers of 2, we get 2 to the power 6 multiplied by 5 cube. So this is the factors of the number 8000, prime factors, where having the powers, prime factors are having powers. So we can see both the power 6 and 3 is a multiple of 3. So hence the number 8000 will be a perfect cube. This is a perfect cube as the power 6 and 3 are multiples of 3. 6 and 3 are multiple of 3. If any number, if we express it as the product of powers of prime numbers, then if all the powers of the prime numbers is a multiple of 3, then the number is a perfect cube. What about so I hope you got the idea. You can do the rest of the problems. So the finding the prime factorization is a very major and crucial step. Okay. Problem number 5, it's saying which of the following are the cubes of even numbers. Now we know that the cubes of even numbers is an even number and cubes of an odd number is an odd number. So the question is asking which of the following are the cubes of even numbers. So 216 is a cube. 216 is even. This implies 216 is cube of even number. So which of the following are cubes of even numbers? Okay. So this is asking which of the numbers are the cubes of even numbers. 729 is odd. So this implies 729 is cube of odd number. I hope you got the idea and you can. So 512 is even. So this implies 512, if it is a perfect cube, then it will be is cube of even number. Okay, so I will not do the rest of them. 3375, it is an odd number, so it is not a cube of an even number, and the 5000 is also 1000 is an even number, so definitely it is a cube of even number. So let's 6, problem number 6. It is now asking about the odd numbers. Which of the following are the cubes of odd numbers? So the answer. So I am just writing those numbers only which are cubes of odd numbers. They will be definitely 125 since it is odd, and then 343 also since it is odd. 1728 is an even number, so it will not be a cube of an odd number, and 4096 is also an even number. So and the last one 9261 is also cube of an odd number because the number 9261 is an odd. Okay. Now problem number 7 I already did in part 1. Problem number 8 I also did in part 1. Problem number 9, did I do it? Problem number 9. Yes, I think I have done it, 9 and 10. Okay. So exercise 4b is find the value of each of the following using the shortcut method. That is, find the cube of 2-digit numbers using the column method. Okay. Okay, I think I have covered most of the problems. But let me do some two more problems regarding this to how to find the smallest number by which a given number must be multiplied to make it a perfect cube, and the smallest number by which a given number must be divided to make it a perfect cube. For that, let me take some examples from the book. Okay, so let's say the number is, let's say we have to find, so let's say what will be the least number that must be multiplied to the number 3087 to make it a perfect cube. So definitely first we have to do the prime factorization of this number. So this is where I normally struggle. Now 3. Okay, so I think it is divisible by 3. So 3 1 0 2 9. Then what? 3. Yes, okay. So 3 3 3 9 4 3, and 343 we know is definitely a cube of 7. Okay, so 3087, its prime factorization will be 3 multiplied by 3, and 343 we know it is 7 multiplied by 7 multiplied by 7. So this is the prime factorization of the number 3087. Now we have to find the least number that must be multiplied with this number to make it a perfect cube. We can clearly see that this is not a perfect cube because it is not forming, all the prime factors are not involved in a triplet. So if you remember the steps of how there are 5 steps of how we determine the least number that need to be multiplied to a given number to make it a perfect cube. The first step was to this was the first step to find the prime factors of the given number. The second step was to uh, form the triplets from the prime factorization. So we can see that 7 multiplied by 7 multiplied by 7 is forming a triplet, and we can see that 3 multiplied by 3, this is left behind. This is not part of a triplet. Now the step 3 was from step 2, after you have formed triplets, identify all the factors as their power which is not part of any triplet. We can see that this the factors 3 and 3, it is not part of any triplet. Now what is 3 multiplied by 3? It is 3 square. So we have to identify all the prime factors from step 2 which is not part of any triplet, and in those all factors you merge the similar factors as powers, and so those powers in the notes I have referred as x to the power m. So that is in step 3, identify all those x to the power m where x is a prime factor of the given number, x to the power m identify from step 2 you identify all the factors, all the prime factors which is not part of any triplet. Okay, now you may have a lot of those factors. In those factors, if there are similar factors, you merge all the similar factors, do the product, so it will have some powers. So that power I am referring as x to the power m. So I have to identify all the different x to the power m from step 2. So which in this problem is 3 square, because 3 and 3 is not part of any triplet, and 3 and 3 are the same prime factor. So if I merge them, it will be 3 square. Okay. Now the step 4 was from all the x to the power m that has been identified in step 3, from the x to the power m, compute x to the power 3 minus m. So if you have multiple x to the power m identified in step 3, for all those x to the power m, you find the corresponding x to the power 3 minus m. So in this problem, these 3 square will be 3 to the power 3 minus 2. This is 3. So the final step 5 was the least number that need to be multiplied with the given number is the product of all the x to the power 3 minus m that has been identified in step 4. So definitely this number in this problem that required this number to be multiplied will be equal to, since in the step 4 we have only one such 3 to the x to the power 3 minus m, which in this problem is 3, the least number to be multiplied is 3. And definitely we can see that 3, when we multiply 3087 with 3, what we get is 3 multiplied by 3 multiplied by 3. This is one triplet, and 7 multiplied by 7 multiplied by 7. This is another triplet. So this is 3 cube multiplied by 7 cube. This is equal to 21 cube. So after multiplying the least number, which is 3, to the given number, which is 3087, we get the number. We get a number which is a perfect cube, and that perfect cube is the cube of the number 21. Okay. Let me do a problem where we have to find the least number that to be divided to a given number to make it a perfect cube. Let's say mm, what mm, let me see if I have. Let me take a problem from. Okay, let's see 1536. 1536 is the number, given number, and we have to find the least number that need to be divide. What is the least number? What is the least number which we should divide the given number 1536 to make it a perfect cube? So the problem statement says by what least number should 1536 be divided to get a perfect cube. Okay, so we have to find the prime factorization of 1536. Let's quickly do that. 1536, it will definitely it will definitely divide with 2, so 7 6 8, and again 2 3 8 4, again 2 1 9 2, and then we have 2 9 6, and then 2 48. Okay, 6 8. Okay, so 2 24, 2 12, 2 6, 2 3. I hope I did it correctly. This was a problem from, I'm taking an example problem from exercise 4D. This was a multiple choice question. The choices are 3 4 6 8. Let's see, 3 4 6 8. Okay, so let me quickly check if I did the prime factorization of 1536 correctly or not. 7 14, 6 8. Okay, 2 3 6 8 4. Okay, 2 1 9 2. Okay, 2 9 6. Okay, 48 24 12 6 3. Okay, so this is how many 2's are there? 1 2 3 4 5 6 7 8 9. So I am writing in short form. This is 3. So the prime factorization is 2 to the power 9. That is, there are product of 9 2's and multiplied by 3. Now this 2 to the power 9 we can write is definite. Okay. So okay. So let it write it down. The prime factorization completely. So we have 2 into 2 into 2. This will make one triplet definitely. There will be another triplet of 2's. There will be 3 triplet of 2's. And we have the only prime factor 3 left behind, which is a not part of any triplet. So this was step 1. Now you can, this was step 1. We did the prime factorization. Now the step 2 is same. Basically we have already done step 2. So step 2 is we have to find the triplets. We have to form the triplets of equal factors, which is we have 3 triplets where each triplet is having an equal factor of 2. So we are having 3 triplets and this 3. So this is the step 2 where we form the triplets. Now in step 3 we have to identify from step 2 which are the factors not part of any triplet. This is the only factor which is not part of any triplet, and so this is 3, this is 3, this 3 means 3 to the power 1. So like this, in some other problem, in some other number, we might have multiple such factors, multiple such different prime factors which will not be part of any triplet. So for all those different, we have to, for all those different prime factors which is not part of any triplet, we have to merge the equal factors as powers, and those powers I am referring in as per the notes as x to the power m. So we have to identify all those x to the power m in step 3, which in this problem there is only such x to the power m which is 3 to the power 1. Okay. Now in step 4 is that from all those x to the power m that we have identified in step 3, we have to find. So this was finding the all those x to the power m. where the prime factor x was not part of any triplet. And obviously, and this can only be 1 or 2. Also note that this m, so all the prime factors which is not part of any triplet, if you merge the similar prime factors and do their product, the powers which can only be 1 or 2. So in step 3 you find all those x to the power m, and in step 4 from all those x to the power m obtained in step 3 you find the corresponding x to the power 3 minus m. So in this case problem we will have 3 to the power 3 minus 1, which is equal to 3 square, which is equal to 9. So definitely the least number, oh I'm sorry, this is about, I'm very sorry, this is about the least number that what is the least number by which 1536 need to be divided to make it a perfect cube. So I was solving it, I was following the steps of to find the least number that need to be multiplied. So step 4 is not required. I'm really sorry. Step 4 is for finding the least number that need to be multiplied. So once we have the step 3, we have identified all the x to the power m. We will now get the result, that is the least number to be divided, least number to divide the given number, to divide 1536 by, to make it a perfect square, to make it a perfect square will be all the product of all the x to the power m identified in step 3, that is 3. So we can clearly see that 1536 divided by 3 is nothing but, in the prime factorization you can see there is only 1 3. If you remove that, that will get removed, and we will have 2 cube multiplied by 2 cube. Actually this will be 2 cube. We have 3 triplets where each triplet is having an equal factor of 2. So the prime factorization of 1536 is 2 cube multiplied by 2 cube multiplied by 2 cube, and we have the 3, this whole divided by 3. So 3 cancels out. So this is equal to 2 cube multiplied by 2 cube multiplied by 2 cube. This is nothing but 2 multiplied by 2 multiplied by 2, this whole cube, this is 8 cube. So the answer will be the least number that need the least number by which 1536 need to be divided to make it a perfect cube is 3. So this is all for this video. I wanted to solve a few more problems based on the concepts that I have discussed in part 1. So in part 1 the video was already very long and my machine was getting very slow, so I couldn't solve more problems. So I had to make a separate video to solve more problems from exercise 4a and 4b. I hope this video was beneficial. This will help you to understand how the concepts from part 1 is applied to solve the problems. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In the next video I will start the next topic, that is cube roots, and possibly we will solve the problems of exercise 4. Let's see, we will solve the exercise 4C and 4D. 4D is an objective question, that is for exercise 4D is objective questions which is based on the entire chapter. So I will solve in the next video, while discussing cube roots, I will solve the problems of exercise 4C And then in a separate video, I will solve the objective questions, that is exercise 4D. So please stay tuned for the upcoming videos. Thanks for watching, and until the next video, take care and bye.